the average profit. That is the profit divided by the number of units. The same thing with cost is C of X divided by the number of units. And the same thing with revenue is the revenue divided by the number of units. Since we are here, let's look at one problem. You choose. You prefer average profit, average revenue, average cost. Which one will be more interesting? Last time I think we looked at the average, what was it? I think it was the average profit. Yes, it was profit. Okay, let's look at the average cost this time. So we have a company that produces any type of product that you can think of, and they have this particular cost function, 375 plus 0.75x raised to 3 over 4. Find the rate at which average cost is changing when 81 items are produced. So the rate of change of average cost when x equals 81. That's the question. So first we have to write the average cost. The average cost is this. And I would like to simplify it as much as possible. So this is 375 plus 0.75 x to 3 over 4 divided by x. I know that since I'm asked to find the rate of change of this function, I have to find the derivative. I'm not going to, I refuse to use the quotient rule of this because there is only one term in the denominator. If I have this, then I have no choice. But I don't have that. I can separate this fraction in two fractions, and I'm going to do that. So one fraction will be 375 over x, or 375 times x to negative 1, plus the second fraction is 0.75, but from 3/4 I subtract power 1. So 3 over 4 minus 1 is going to be negative 1 over 4. See if this is okay. Is this okay? Any questions? So we copy the base. Imagine that I separate into two fractions, this over this, which is this, and plus 0.75, this divided by this. So x to 3 over 4 divided by x, I subtract from the exponent of the numerator, from 3/4, I subtract 1, and I have negative 1 over 4. This is what I am going to differentiate. Okay? So then the average rate, the rate of change of the average cost is, I bring down negative 1, so negative 375, I subtract 1 from the power. I bring down negative 1 over 4, so I'll have negative 0.75 over 4, multiplied by x, negative 1 over 4, negative 1 over 4 minus 1 will be negative 5 over 4. Okay, at this point, we are asked to evaluate this function when x is 81. So that's what I'm going to do. So we normally like to write this when x equals 81. And we can continue. So, of course, negative 375 times 81 to negative 2 minus 0.75 over 4 times 81 raised to negative 5 over 4. So, I spilled water on my calculator by mistake, of course, and I removed the battery and everything, so I think it's working. So negative 375 in parentheses 81 close caret in parentheses negative 2 minus in parentheses 0.75 divided by 4 close the parenthesis, open another one with 81, close it, caret in parentheses negative 5 divided by 4 and press enter. So I got negative 0.0579. Measurement unit, of course, is dollars per unit. The average rate of change of the cost with respect to units. Any questions? All the others are the same, meaning if we're asked to find the average revenue, the rate of change of the average revenue, average cost, average profit, all the same. That being said, I am going to start, I do have other colors too. I'm going to start or continue with 1.7, the chain rule. I thought that these were better, but I don't think they are. Okay. Well, we're really talking about what is called function composition. I'm not talking about the sum, the difference, the product, or the quotient of functions. No. No, I'm talking about a function inside another function, for example. And we looked at something like this. Let's say I have the square root of x squared minus 3x. Can anyone identify which is the inner function here and which is the outer function? Which is the function that we apply first to x, and which is the function that we apply second? Yes, answers may differ because we can come up with more than two functions. So what would you say the inner function would be for this function? Obviously it's a composition of two functions. It's not a quadratic function, and it's not a radical function or square root. It's a combo of those two. But now I need to identify which one is the inner and which one is the outer. Can anyone help? Anyone?
Is the inner, not the inner, outer, sorry, x squared?
So it depends on what we evaluate first. If I ask you to evaluate it for x equals 0, will you do the square root first?
Yeah.
You cannot.
No.
You cannot apply 0 to the square root. You have to evaluate this function inside, and when you're done and you get whatever, then you take the square root from it. So then one more time, what is the inner function?
3x.
The inner function is x squared minus 3x. You're right. There are other answers. This is not the only answer. I agree. So this is the inner function. When I'm done with this and I get a number, then I apply the square root of x to it. So this is the inner, and this is the outer. Why is this important? It's because of what it's called the chain rule. So first we really need to know how to identify the inner and to identify the outer in order to learn the chain rule and understand how it is applied. Okay, here's another example for you. And let's say f of x equals 3x plus 1, everything to the fourth power. Can anyone give us, there is more than one correct answer, the inner and the outer?
Would the inner be 3x plus 1?
Excellent. And what will be the outer? When I get one number, I got one number here. What function do I apply to this number?
To the power of 4?
X to the 4th power. Exactly. That's the function. I have to say x to the power 4. Because the power 4 doesn't mean anything. I have to say the function is x to the 4th. Okay, one more, and then we'll start the chain rule. So let's say we have f of x equals 1 over 3x plus 1 squared. There is more than one correct answer. Yes, you can decompose this in more than one function. But for now, let's just say the inner and the outer. There are more than two functions in here. But let's just choose an inner and an outer, because we will decompose it in more than two, but just to have an idea. Just to make sure we understand this. So the inner is okay, let's decompose it in everything. So the first step must be the 3x plus 1. When I'm done, I have to square. So outer 1, if you want. And outer 2, which is the last one, is 1 over x. So first I perform this as a number. Then I have to square the number. Then I get a number here, which is now, I apply to that number 1 over x. So this function indeed has three functions that make it up. So let's start back to two functions. So the function composition the general situation is f comp g. This is a circle, not too big, not too small. So this is read f comp g, which means the composite of f and g. We can go on forever. G comp f, f comp f, f comp g comp f. I can go on as any level you want. But let's stick with these two for now, and basically any notation is good enough. So how do I differentiate any function composition? So this is the general form. F comp g of x, first of all, by definition, g is the inner because it's the closest to x. It will be applied first. And this is the outer. So this is the inner, and this is the outer. So it's the same with f, outer, of the inner. So f comp g is the same with f of g of x. And to explain further, we're going to look at examples in a minute, but to explain further how this is created is very simple. To x, we are applying function g. That's the first function I apply, the inner. And I get a number, which is g of x, whatever, but it's a number. And I apply now f to it, which is the outer, to get f of g of x. That's how it works. Finally, how do I differentiate this? So differentiating f comp g of x is obviously the same with differentiating f of g of x, because that's what they are, that's what this one is. That's what f comp g is, this. And now, remember how we decomposed it? We went from the inner to the outermost. Well, when we differentiate, we should go the other way. I differentiate the outer. I get f prime of g of x, and now times the inner function prime. So this is what we call the chain rule. Now, what if I have a function raised to power n that I'm asked to differentiate? Before we discuss this one, let's go back for a second to x to the nth power prime. What do I get when I differentiate x to the nth power? Can anyone refresh our memory? How do we differentiate x to the nth power? N times x to n minus 1, and I should write, and I did that some time ago, times x prime. But there is no need, because we already established that that is 1. So now coming back here, see how many props I have? Just kidding. So coming back here, this is the chain rule. Bring down n, multiply by the function raised to n minus 1, but this time this is not going to be 1. It could be 1, but I still have to write it as f prime. N, the function to n minus 1 times f prime.